People will be impressed. Okay, so we have a piece of wire. Now you don't want lithium gutters. Stop that. They will only last like a day. You'll get a nice. The crowd that joins around will be nice. But they'll watch it reacting in the first rainstorm.
That is cool.
That would be exploding and blowing out. Totally weird and wild. I like the way you think. Alright, I'm suspending this piece of copper in this test tube. Pretty good, huh? Not bad. I've been practicing. Okay, what I'm going to do is I'm going to pour some silver nitrate onto this copper. Now, if you remember, copper is not real active, but silver is even less. So the copper will replace the silver. So how will the silver appear to us? Sort of in a dream? No. It actually starts to cover the copper coil. So you'll see the copper coil covered with pure silver. Beautiful, shining, shimmering silver.
I like shiny.
Okay, watch carefully as this reaction takes place. Alright. And you say to yourself, hey, nothing's going on. But watch carefully, look at that copper real carefully. Start to see it turn gray.
I see it.
It's turning color as we watch. It's not molding. That's silver. And you say, hey, wait, time out. Silver's shining. That looks just black or fuzzy. And I say, you're right, because there's so little silver there right now, the light can't reflect it yet. But as the silver crystals scrub, shimmering, shiny silver will appear out of like nowhere. But of course it's not out of nowhere, it's from the solution. So, alright, see how it's getting fuzzy?
Yeah.
Fuzzy wuzzy?
Had it.
Fuzzy wuzzy? Fuzzy wuzzy? Wasn't very fuzzy. Wuzzy. But he is now. He's getting fuzzy. Alright, so some of you will get bored, within 5 nanoseconds of this. So I have, like the cooking channel has, the before and after. This is what becomes. Now this time I used a strip. Look how fuzzy wuzzy this one is.
That's fuzzy. Can we burn it fuzzy?
Can we burn it? No, it's an aqueous solution. You can't burn that. Now, if you look very carefully, you might see some shine or shimmer to it, but it might be difficult to see. It does look like mold. It's not. It's silver.
How long until it becomes like
well, that one may never actually use. Yeah, 80 years. Come back.
Look how fuzzy it's
come back when you're retired. No, but anyway. Sometimes you don't really ever see the shininess, unfortunately, on this one. But, you might be able to see it a little bit on this already. Oh, well, anyway. All right, so we'll look at it. Some of you might notice, some of the more sharp-eyed of you, might notice that the coloration of the aqueous solution has turned a little bit. Does anyone see a bluish tinge?
Yeah, sort of.
How about just a white background?
Wearing a white shirt, you get stuff like that.
Well, I don't want to put silver nitrate in every shirt. You guys might remember. Do you see any bluish tinge to the solution, especially in this one? Yeah. Okay. Bluish tinge. Okay. All right. So, okie doke. Now, some of you were puzzling yesterday about elephant toothpaste. You loved that demonstration so much. You were wondering if you could do it at home with your 3% hydrogen peroxide. Shall we see?
Yeah.
You can't buy the 30%. Not without.
I think boil away the water and that, like make it concentrate. Let's do it.
That's a good question. I don't know. I'm pretty sure that's not how you could do it.
Let's try.
Because if you heated this, it would decompose it. So we break it down into water and oxygen. So, no.
You use like 10 times as much.
I don't know exactly the manufacturing process of hydrogen peroxide. It's a good question, though, guys. And I like that question. It's good. Okay, so elephant toothpaste, 3%. All right. Now, I told you yesterday. Now, of course, the elephants like color, even though they can't see it.
They like blue, I thought.
No, they can't tell it.
Put the blue in too and make it purple.
They just want to.
Make it purple. Make it purple. Yeah, good idea. Make it purple. Make it purple. Do it.
Gosh. I'm glad you guys aren't elephants. I don't know. This. Not sure how the elephants are going to like this, but okay.
Hey, that's not blue.
Is that your elephant imitation? It's good. It's good. It's good. Thanks. You're welcome. All right. Now, yesterday I used potassium iodide as a catalyst, but there's lots of things that can catalyze this decomposition. Blood, remember? Blood. The catalase found in blood. The catalase found in potato peels, potato strips, and various other things. I mean, you can check for catalase in a substance or a catalyst by spreading some peroxide on it. So you can go around and, capture a worm or something. Oh, it's fizzy. It must have catalase. Worms won't like it. But cat. No, cat. I'm sure cat blood would also. We're not going to do that. Okay. All right. So we're just going to. But here I'm going to use some manganese dioxide. The same thing I catalyzed the decomposition of potassium chlorate with. This is a really good catalyst. So we'll pour some in. We'll see if we get any foaming. Now, don't expect as much as you saw yesterday, right?
Toothpaste.
Well, because it was only 3%, so I don't think you'll see really a heck of a lot. It didn't turn really purple.
Chemistry failed.
Nothing failed.
Hey, it's still going
not
up.
fail.
Still going.
It's going. It's just not going really rapidly because it's not that concentrated. What can we say about... Now, listen, there's an interesting connection here between what we saw today and yesterday. What can we say about the rate of a reaction compared to the concentration or the amounts of reactants? Is there a connection that you can make? Guys, listen up. This is important. Remember yesterday when I dropped the thing into pure oxygen, highly concentrated oxygen? We saw the reaction go quickly. Then we had 30% hydrogen peroxide. The reaction went quickly. So I'll try a little of this catalyst. Sometimes the homogeneous catalysts will work a little better because they can get down in there. So this looks like something, you might be able to get a little mileage out of it around Halloween time or something. Cool. Oozing, put some oozing, I don't know, beaker of blood or something, But other than that, it's really slow. It's slow, right? So.
Can we do the other one again?
No, I already did that twice for you guys.
One more time.
You guys are at your limit. I gotta say you guys.
That stuff.
Go the whole
That's
street with it and do it.
Yeah,
Well,